we have two rows and two columns in our data set, we can do this chi-squares by another method. This is called as 2 by 2 contingency table, and we have two columns and two rows, and these are our individual data points. So our data is right here, the numbers, the actual numbers on which we're going to operate. And we have for example a variable which is here, so that has two levels, and that's there in the columns, and there is another variable on the rows, and again it has two levels. For example, we might have genders, male and female, and the answers are yes or no. So in this case we can get it as a 2 by 2 contingency table. So we can get the chi-squares with this formula. Over here, C1 is the column 1, and the sum of the numbers in this column, and that's there in the E. So E is the column 1 total, and F is the column 2 total. Same way, row 1, summing over A and B, the row total is G, and for row 2 it's H, and N is the overall sample size, or the overall total, grand total. So we can get the chi-square as A into D, something like a cross product, N minus C into B, or B into C. So AD minus BC square into N divided by EFGH, the respective totals for the columns and the rows. Let's elaborate this with this example 13.3 from the book, Ayman's book, the side effects of medicines. So two medicines are being compared regarding to a particular side effect, and we have 60 similar patients, and they are split into two groups at random, and one on each drug. And then we have observed the raw data as follows. So these are the drugs on the rows, cure all and quick fix, and side effects versus no side effects. So cure all has side effects for 10 persons, and quick fix has the side effects on 5. So total side effects were 15. 45 did not have any effects. Among them 20 were for cure all and 25 for quick fix. Total we have 30 and 30. 30 patients were given cure all and 30 were given the quick fix, and total number of individuals, or this sample size, or the grand total, is 60. So we plug in these numbers as per this formula, applying this 2 by 2 contingency table thing, and what we get, the numbers like this, and the chi-square is 2.22. so that's our chi-square calculated. So we can go to the table and calculate the chi-square critical. So that is here. This data has two rows and two columns. So we have again the degrees of freedom as column minus 1 into rows minus 1, that is 2 minus 1 into 2 minus 1. So the degrees of freedom here are is 1. So for 1 degrees of freedom and 1 tail to the right, the alpha value is 0.05. So our chi-square calculated is 3.84. So we do the hypothesis testing as our procedure is a chi-square test of independence, and our population, underlying population regarding which we are doing this hypothesis testing is all patients who would be given these drugs. But right now we have a sample of 60 patients, and 30 were given both of these drugs. So we have the null hypothesis as drug type and side effects are independent, that is chi-square is equal to 0, versus they are dependent, chi-square is equal to, or it's greater than 0. And our chi-square calculated is 3.84 for 1 degrees of freedom, alpha 0.05. And now what we do over here is we calculated this chi-square as x square from that formula for this contingency table, and our calculated number was 2.22. And since our chi-square calculated is less than chi-square critical, we fail to reject the H naught at alpha 0.05, and we state that we do not have enough evidence to state that the drug type and the likelihood of side effects, they are statistically dependent. So they are not dependent on each other, they are independent. So this shape of chi-squares is called as 2 by 2 contingency table.